Welcome to this lecture. We want to look at solving radical equations again, but before we do so, let's review squaring binomials. We have 2 minus the root of x all squared. Let's work on that one together. We know that this means we have 2 minus the square root of x times 2 minus the square root of x. Make sure that because we have a minus sign here, each of these has a minus sign because we're squaring the binomial. We're multiplying that binomial by itself. So I have 2 times the second bracket minus root x times the second bracket. Again, some of you might have a formula for squaring this binomial, and that's fine. You can go ahead and use it if you know that formula. Negative root x times negative root x will be positive x. I see we have like terms here. So we have 4 minus 4 times the root of x plus x. Why don't you pause your video and solve the second one? Again, we have the square root of 3x minus 4 multiplying itself. They both have negative signs. The root of 3x multiplied the second bracket, negative 4 multiplied the second bracket. We have like terms here, so we have 3x minus 8 times the root of 3x plus 16. We're going to use that now as we go ahead and solve these radical equations that contain 2 radicals. Now you'll remember when we were solving radical equations in the last lecture, we said that we should always isolate the radical. But as you can see in these examples, we have more than one radical. So I'm going to suggest that we isolate the more complicated radical first. Oops, I don't have room to write that. Isolate the complicated radical. So in this case, the root of x minus 1 is certainly more complicated than the root of x. And we can see that that radical is by itself on the left side of the equal sign. So the next step is to square both sides. So we see on the left side, the root of x minus 1 all squared is x minus 1. On the right side, we have to square that binomial. That's that practice we were just doing in the questions above. Root of x multiplies the second bracket, minus 1 multiplies the second bracket. Now you can see we have a radical again, so we want to isolate our radical. We can simplify this, subtract x from both sides. I'm going to add add 2 root x to both sides. Add 1 to both sides. Now we can divide each side by 2. And now square both sides. So whenever you have more than one radical, you're going to end up squaring both sides twice. And remember, just like for all radical equations, you have to check your solution. We use substitution to do that. So we're going to substitute 1 in each of these. The square root of 1 minus 1 equals the square root of 1 minus 1. This is the square root of 0. 1 minus 1 equals 0. We know this is a solution. Why don't you pause your video and try question 2. The first thing I did was isolate the more complicated radical, the square root of x plus 8. Now we can square both sides. We can simplify each side and isolate our radical again. Finally, we can find the square root of, we can square both sides again and solve for x. Like all radical equations, we have to check our solution. So we've substituted x equals 1 into all of our values of x. The square root of 9 is 3. Square root of 1 is 1. Negative 1 equals negative 1. This is our solution. There are 4 more questions here for you. I'm going to stop this video. We'll come back in the next video and finish these.